Hello everyone. In today's video we're going to be talking about, or rather introducing, discrete mathematics as one of the courses and the program computer science. We might be asking ourselves to say, what is discrete mathematics, and why study discrete mathematics? What are mathematical models? How can we apply this discrete mathematics? The content, or rather the outline for this video today, is as follows. We're going to describe what discrete mathematics is. We're going to talk about why we should study discrete mathematics. We're going to talk about mathematical models. We're going to talk about abstractions, what they are. We're also going to talk about how discrete mathematics can be applied and some recommendations given by the University of Mulungushi. Just to zoom out a bit. What is discrete mathematics? So, in simple terms, discrete mathematics is a part of mathematics that is devoted to the study of discrete objects. Discrete, it means distinct or unconnected elements. So to make this as one definition, we can say discrete mathematics is a branch of mathematics that deals with discrete objects, often finite objects like computers, and it is interested in sets of objects with discrete properties. Sets of objects with discrete meaning distinct, or rather say different objects. This discrete mathematics, unlike most of the maths that have been seen before, most of them are aimed at processes, real numbers, calculus, mechanics, etc. But discrete mathematics is mainly based on discrete or different properties of objects. We move on to what we're calling mathematical models. What are mathematical models? So to describe this, I'll move to the next slide. Mathematical models. So a mathematical model is simply a way to represent a real world situation using mathematical concepts. A mathematical model is simply a way to represent a real world situation using mathematical concepts. These mathematical models, they help us understand, predict, and analyze a phenomenon by abstracting key features, or by ignoring key features like resemblance to reality, the descriptiveness of a phenomenon, the predictiveness, abstraction, universality, or the clarity of thought. So here's an example of a mathematical model, which is Newton's second law of motion. So this when you look at this equation there, Newton's second law of motion, it says force is equal to mass times acceleration. Excuse me. Now, why are we saying this can be given as an example of a mathematical model? So why that is because it models how force is related to mass and acceleration. It is a classic example of a mathematical model where you measure the mass and the acceleration, you calculate the force, and then you can predict how an object will move by measuring the mass, the acceleration, and then finding the force. So models like this, models like Newton's second law of motion help engineers, scientists, and programmers to design systems, to solve problems, and to make decisions. I'll repeat that point. Models like Newton's second law of motion, they help engineers and scientists, including programmers, to design systems, solve problems, and make decisions. Not only that, but particularly in computer architecture, similar modeling helps predict CPU performance and memory usage of a computer. So we talked about abstraction in the outline. What is abstraction? Might be asking ourselves that question. So abstraction is one way in which the human mind uses to manage complexity, or you can say abstraction is a method of simplifying complex systems by focusing on the essential features and ignoring the irrelevant details. So we've been given an example here which says Newton's laws of universal gravitation. So this is Newton's law of gravitation in physics. So this law can predict planetary motion by treating planets as point masses, ignoring their size, their shape, or the atmosphere. So that part where they ignore the size, shape, and the atmosphere, that now is what we're calling abstraction. Then abstraction is used to simplify description of complex objects by ignoring important features, just like I have explained about Newton's law of gravitation there. So in computer science, there's need to model discrete mathematics, or to in computer science there's need to model discrete objects, or rather say finite objects, such as state of memory, databases, process of computation, hardware, programs, knowledge bases, parallel computing, etc. etc. Excuse me. So what is meant by the state of a memory? So in computer science, discrete mathematics is used to model memory as finite set in bits or addresses. It uses set theory and logic to organize query data in databases. It describes algorithms and finite steps using logic and automata theory in processing of computations. It not only does that, but also models circuits and logic gates using Boolean algebra in hardware. It also represents control flow and data structures using graphs and logic in programs. Discrete mathematics uses propositional and predicate logic to store and infer knowledge in knowledge bases. Last but not the least, discrete mathematics models tasks and dependencies using graph theory in parallel computing. That is what discrete mathematics models in computer science, or what it does as part of computer science. And then moving on to the applications of discrete mathematics, which are quite straightforward. Discrete mathematics helps you find ways in which you can choose a valid password for a computer system. It also helps you to figure out the probability of winning a lottery. It is the linkage between two computers in a network. Discrete mathematics helps you figure out the linkages between two computers in a network. It helps you identify spam emails. It can help you encrypt a message so that no unintended recipient can read it. That is what discrete mathematics can be used for in computer science. Here are some other reasons or applications of discrete mathematics. Discrete mathematics can be used to find the shortest path between 2 points in a city using a transportation system. It can also help you list integers to be sorted out so that the integers are in increasing order, or how many steps are required to do such sorting. That is discrete mathematics. It can also help you prove that the sorting algorithm of the list is correctly done. The sorting algorithm of the list is correctly done. Discrete mathematics can help you know how you can add a circuit to two integers being designed. It can help you know how you can add two integers in a circuit that is being designed, and how many valid addresses, or rather say internet addresses, that can exist. We may be asking ourselves to say, why should we study discrete mathematics? So discrete mathematics provides the ability to understand and create mathematical arguments. It can also train students on how to think logically and mathematically, exposing them to mathematical reasoning and different ways problems can be solved. Note that discrete mathematics, or rather say without abstraction, the human thought could not have no progress. We earlier mentioned to say abstraction. These are ways that the human mind uses to manage complexity. So without this abstraction, human thought could have no progress in life. Here are more reasons why discrete mathematics should be studied. It provides a background for solving problems in operation research, in chemistry, in engineering, in bioinformatics, biology, and so on and so forth. It not only does that, but also provides mathematical foundations for many computer science courses, such as data structures and algorithms, database theory, automata theory, and formal languages, compiler theory, computer security, and operating systems. So that is why we can study discrete mathematics. And then here are the recommendations given by the university to say, in order to improve in discrete mathematics skills, you need to work on and solve as many exercises you can, and these exercises will be provided at the end of each lecture slide or PowerPoint lecture presentation. And then we've been encouraged to solve some additional exercises from prescribed books, and here are some of the prescribed books by the university. These are the books we should take a look at that have been prescribed to help you best understand or improve your skills in discrete mathematics. So that's all for today in discrete mathematics. Next time we're going to be moving or talking about proposition logic in the next video. Stay locked in.